we will revise superposition theorem based on a given simple example. So here we can see that we are having one circuit in which there are three sources. Two sources are voltage sources of 12 volt and 6 volt. One source is 3 ampere current source. So according to superposition theorem, what we need to do, we have to see effect of one source at a time. So just remember that whenever we are using current source and voltage source is off, then it will be counted as a short circuit part. Whenever we are taking voltage source and we need to off the current source, so current source will be open circuited. So now see this example. So there can be three cases. First thing, case 1, whenever your 6 volt source is active and other two sources are not active. So just remember that since this 12 volt is voltage source, it will be short circuited. So the resistance is 2 ohm and this current is here, so it will be open circuited. Now we are remaining with 4 ohm resistance and the supply voltage is 6 volt. So now it is very easy to find out the value of I1. I1 will be obtained by simple V equals to IR. Here the applied voltage is 6 volt and the total resistance is 6 ohm. The value of current will be 1 ampere. So just remember that the first current coming due to use of 6 volt sources 1 ampere. Now there will be second case. So assume that case 2, when your 3 ampere source is active and other two voltage sources are not active now. So when the voltage sources are not activated, we will replace this voltage source by short circuit line. So again it is 2 ohm. Suppose this current is I2 and now this current source is activated. It is 3 ampere. This resistance is 4 ohm. 6 volt is shorted now and the last 12 volt is also shorted. So here we are having a single current source activated now. So we have to find out the amount of current flowing through 2 ohm. It will be simply, so just apply current division. So in current division, you know that you have to take opposite resistance. The opposite resistance is 4 ohm. So 4 cross 3 divided by 4 plus 2. Now the amount of current flowing through this 2 ohm will be 2 ampere. This I2 value is 2 ampere. So it is already obvious that this 2 ohm is less resistance, is having less resistance value than this 4 ohm. That's why it is having higher current. So 2 ampere will be flowing through 2 ohm resistance and 1 ampere will be flowing through this 4 ohm resistance. So now we have obtained I2 value as 2 ampere. Previously we have obtained I1 as 1 ampere. So the third case, the only remaining source is this 12 volt. So when your 12 volt source is activated, in this case the second source, which is of 6 volt, it will be shorted and this current source will be open circuited. So now it is 2 ohm. Since the direction is already specified, we cannot change the direction now. This is 12 volt, the current source will be open circuited and now the 4 ohm resistance is as it is and this will be shorted here. So if we have to find out the value of I3, here generally I3 value will be equals to 12 by 6. It will be 2 ampere. But remember that the polarity is different for this voltage source. So we can say that the I3 we have assumed is opposite to the current flowing through the circuit. So I3 value will be equals to minus of 2 ampere. Because we can see that in the previous case, whenever we are having 6 volt supply, this is negative terminal, this is positive terminal. So this I1 is already following the polarity of this voltage source. But in the third case, when we are having 12 volt, it is not following the polarity, it is opposing the polarity value. So that's why I3 value will be equals to 2 ampere. So that whenever we have to find out total current across 2 ohm resistance, it will be I1 plus I2 plus I3. So we have taken I1 due to effect of 6 volt. So it was coming as 1 ampere. Next, the I2 value, which was due to 3 ampere source, it was 2 ampere. And now the I3 value due to this 12 volt source, it was 2 ampere. So the total current flowing through the circuit is now only 1 ampere value. This is the final value of current flowing through this 2 ohm resistance. So we can see that we have obtained the value of current due to different sources here. So mostly this theorem is applied for calculation of current and voltage independently. But see here, if we are calculating power one by one, suppose it was P1, it was P2, it was P3. So since P equals to I square R, and when we are squaring the I3 value, it is already negative, but after squaring it will be giving you positive value. So we cannot use directly this theorem for power calculation or power addition. So once total current is obtained, now we can find out the total power absorbed or delivered across 2 ohm as P equals to V into I, or I square into R. This I value is 1, R value is 2, the power will be simply 2 watt here.